Hi guys, what we're going to do today is take our normal equation y equals mx plus c and introduce it and explain how we've come about this one, because in certain scenarios we can't actually use the y equals mx plus c form. We need to have it in this other form, and you'll see it's exactly the same thing, just written in a different format. And to explain it, I'm going to use an example. So let's take something easy like the equation 2x plus 1, so that would be 5. If I make this a 4, that would have to be 9. So here we go, we have two coordinates and you'd want to find the gradient of these two. So normally we would say something like y2 minus y1 over x2 minus x1. We would then do 9 take away 5 over 4 take away 2, and we'd get the gradient of 4 over 2, which is 2. Now, what about if we didn't tell you this? What happens if I said, well, we don't know what this coordinate is here? Now, if we think about what we called this one originally, we said that was x1 and that was y1. So now what we would have is m is equal to y2, but in the question they called it y, and take away y1. So I'm just going to keep it there because I'm not using the numbers because we're trying to prove this formula here. And that's divided by x2, which was this one here, so that's x. And the reason I'm not putting x2 is because this is what they gave me in the question. And x1 was there, so that bit's the same. Now, we've got divided by all of this, so we have to get rid of this. You see there's no division in this formula, so we're going to times both sides by all of this. So that would give me m brackets x minus x1 is equal to y minus y1. And there you have it. That is the formula, just the other way around, because we like generally starting with a y. So it's not actually anything different to what you've seen before, it's just written in a different way. So we're going to try and put this into practice now. Okay, so here's a question. So find the equation of the line with a gradient of 5. So you'll notice that they're telling us the gradient that passes through the point 3, 2. So let's write our formula. So it's y minus y1 is equal to m brackets x minus x1. Now, the y and the x are just the same as they are really in y equals mx plus c. We're just trying to find out the other values. So we're going to end up with something in this form. It's just another formula. You can actually do it with this, but try and do it with this one because it will be quicker and less complicated. So, y minus y1. So this is x1 and y1 because we only got one coordinate given to us. So that's going to be 2 is equal to m, we know the gradient, that's 5, brackets x minus x1, which is 3. So if we expand this bracket now, we have 5x minus 15, and we have y minus 2, then it should just fall into place. You add 2 to both sides, and voila! That is the equation of the line with a gradient of 5 that passes through that. And you can do your double check like before. 5x's, 5 3's are 15, take away 13 is 2. So it definitely works. This question's far more complicated. And you know that you'll find these later on in the exercise. But let's just make sure you understand it now. So we've got two lines and they intersect at a point T. So if you think of this one, this is quite steep, and this one is less steep, so they're intersecting at a point T. And you can see here that these lines are both equal to each other. So let's do that. So they're both equal to y, so we can just put them equal to each other straight away. And as soon as you've done this, you then need to think about solving. So 3x here is equal to 9, and x is equal to 3. So basically what this means is where these two meet, the x is 3. So now we need to find the y coordinate. So let's use it in this first one. So y is equal to the x take away 1. So y is 3 take away 1, which is 2. So it means they intersect. Oh, can't spell. They intersect at 3, 2. So it's like this question here, and in fact it's exactly the same coordinate, but they made me work a bit harder to get that. So we need to find the equation of the line with a gradient of minus 2/3 that passes through t. So it passes through this point. So y minus y1 is equal to m x minus x1. So remember, this is x1 and this is y1. So y minus 2 is equal to minus 2/3, that's from here, the gradient, x minus 3. Okay, let's create some space. So that's minus 2/3 of x. So there's our gradient, we've got that. So that's going to be a plus, so 2/3 times 3. If you need to do this to make it easier, do so. But that's going to be 6/3, which is a 2. So we got y minus 2. We need to add 2 now to get the y equals on its own as the subject. And we have that. Now they could go one step further on this question. They could ask you to write it in the form here. So before I move it all over, I'm just going to deal with this denominator here. So on this side, I'm going to times it by 3. No, if I'm timesing this side by 3, I've got to times the whole thing by 3. Of course I have. I don't know what I'm saying. So times it by 3, I'm going to get 3y, and that's going to be minus 2x. So if you think, if I'm timesing it by 3, they're going to cancel out, plus 12. Now I'm going to get everything on one side and write it in the correct order. So it's 2x plus 3y minus 12 is equal to 0. And there you have it. So that's in the form, remembering these must be normal integers. So if you just rearranged it with a fraction, you're going to be losing a mark. So that's as hard as it would go. Just think about removing this, and if it's equals, obviously the both sides are equal, so what you do to one you must do to the other. If there wasn't an equals, you could just do it to that one because you'd be making an equivalent fraction. So I've probably just confused you a little bit there, but just follow the video each time and you'll see for yourself what I mean.